Ngalakin Khadijan Nyunga Boja.
Video 25, the Data Manipulation Language, or DML. So far we've focused entirely on querying an existing database. So I've given you a completed database and then you've actually just made queries on it, but without changing it at all. Of course, in practice, data changes while the database is being used. Throughout the life of the database, new rows are inserted, existing rows are updated, and then obsolete rows are deleted. So the commands for these operations are collectively known as the data manipulation language. The main DML commands in SQL or SQLite are insert, update, and delete. And they're actually all pretty straightforward to use. So this is going to be quite a short video. We've already used insert, which is used to insert a new row into a table. You just have to get the syntax exactly right. Insert into, and then the name of the table, and then the word values, and then either one tuple, in this case, I'm inserting a new student with student number 6, whose name is Derek, or a sequence of tuples, one after another, 6, Derek, 7, Harmony, and so on, as many as you need. And that will just insert a whole collection of new rows into the student table. There's nothing to worry about too much there. There's nothing much that can go wrong. If you don't know all of the information about a particular row, you can enter a null for that value, as long as the column hasn't been declared to be a key or a null column. Updating values in certain rows, we just use the update statement. And this has the following syntax. The word update followed by the name of a table. So the example here is update employees. And then set, and then an assignment to a column. So assigning a value to a column or assigning the value of an expression to a column, and more than one of them if you need. And then where, and then some conditions on the rows. And the update will only occur to the rows that do satisfy the conditions. For example, employee number 1002 gets a new phone extension for his office, so we need to update the employees table to reflect that new extension. And the way we do that is update employees, set extension equals whatever the value is, in this case x5580, where employee number equals 1002. So SQL will look at the table, it will consider each row in turn. If the employee number is not 1002, then it will ignore that row. If the employee number is 1002, then it will take the action and actually change the column extension to this new value that has been specified. Okay, so as long as you think about it in this sort of methodical, step-by-step way, then you will be able to work out what any particular update statement does. So it started off with update employees, so that's the table that's being considered. And then just as usual in any SQL sort of thing, everything is done row by row. So each row is examined, and then the action that was specified, the setting of the extension, will be applied only to the rows that do satisfy the condition. So there's really only one slight subtlety, which we'll come to in the next slide or two. The set part of the statement doesn't have to be setting a value to be a specific literal value. You can set it equal to, you can set the column equal to an expression that involves other columns. If you want to, it can involve subqueries and so on and so forth. Here's a simple example. All I'm going to do is increase the mark by 5 by setting the mark field to be the old value of the mark plus 5. So if the mark was 40 before, then it goes up to 45. Which students am I altering? Well, I'm altering the students who took CITS1402 in 2019. So maybe something happened in 2019 and the marks were too low, and the Board of Examiners said, okay, you have to scale the marks for databases, and so the database's marks were all increased by 5. So it's probably unlikely that the scaling will be a simple +5, but various scaling things do have to happen occasionally. There's just one thing you have to watch out for. If you don't have any condition at all, then that just qualifies as true, and the action happens to every single row. So if you do update enrollment, set mark equals mark +5, but don't specify which rows you want to do that to, then it will just automatically happen to every row. So probably, probably it would be unusual you want to update every entry in a table without regard for what that row actually is. And as before, you can do more than one column at once. So we're still working at one row at a time, but the set statement can change the values, or can change the values of several columns. So here we're sort of building up the university database. We know that Amy is student 1, but we're going to increase the amount of detail we keep about each student. And so we're going to choose names that are now first names and last names, and we're going to add the email as well. So set sname equals Amy Chan, comma, email equals, and then that email address, where snum equals 1. Just one thing, the table actually has to have columns, sname and email for this to work. So we can't use this to create new columns in the table. It's going to alter the values that are currently stored in those columns. Okay, deleting then does pretty much exactly the same thing. It's the same structure, and you just say delete from, and then the name of the table, and then some conditions. Every row that satisfies those conditions will then be deleted from the table. So we might want to remove from the enrollment list everyone who has failed a unit, any unit. Well, so delete from enrollment where mark is less than 50. So the system will look through every row of the enrollment table. It will check the condition, mark is less than 50. If the mark is less than 50, then it will delete that row. Okay, so the effect of this is to simply eliminate from that particular table every student that has failed a unit. In general, you probably wouldn't want to be throwing away information. So, but maybe you've decided that the information on failed students belongs in a different table. So you've moved that information into a different table, and now you're just finishing off by deleting it from the enrollment table. Quick test here. What does this do to the current students who have year 2020 and mark equals null? Do those students get deleted or not? Well, the condition that is tested is whether null is less than 50, and that condition, well, null does not participate in any comparisons, and so that will not be true, and so the marks, the students who currently have null marks will not be deleted from the table. Okay, let's see what how else we can use this, and just one other small sort of feature that may come up. So casting our mind back to the Chinook database, while we were working with that in the lab, we discovered that it had 2 playlists with exactly the same name and exactly the same songs. So The playlist ID of the second of these playlists was playlist ID 10. So what we want to do is we want to just delete all mention of the playlist 10 from the database because it's a duplicate. We're just going to, if we want a new playlist, we'll create a new playlist and add different songs to it. Okay, I'm going to do this in 2 steps. You remember that playlist track, the table playlist track, was a bridge table that listed just a track ID and a playlist ID. And then each entry in there was just a particular track being on a particular playlist. So track 2 maybe was on playlist 10 and so on. What I want to do first is delete all of the mentions of tracks with playlist 10 from the playlist track table. So all of those ones get deleted first, and only then do I want to delete the playlist itself from the playlist list. Okay, so why did I take 2 steps to do this? Why did I delete all of the entries in playlist track before I deleted the entry from playlist? Well, the answer to this can be found in the structure of the playlist track table. You'll notice that it's got a foreign key. So foreign key playlist ID references the playlist and it says on delete no action. So that means if I delete the playlist with ID 10, then all of the entries in playlist track that have playlist ID 10 will become a dangling pointer. There will be entries in a playlist that don't point to a particular playlist. And so the foreign key constraints will prevent that from happening. Finally, don't forget the where condition when you're doing a delete statement. What would happen if you just said delete from student and you didn't have any conditions like deleting a particular student or deleting or any particular condition on the students that you intended to delete? Well, again, if you have no conditions, then then every row satisfies it, and so this statement will end up just deleting all of the rows from student. So you'll end up with a student table that the table will still be there. You'll be able to look at its schema and you'll know that it has the columns that it has, but it will be containing no data. And that's rarely what you want to do. Of course, subqueries can basically go anywhere in SQL that an actual value could go. And so instead of increasing the marks by 5 for students who were taking CITS1402, let's increase the mark of every student who scored below average in that particular unit. So if you're a below average student, you get 5 added to your mark. Okay, so notice that this is a correlated subquery because it has a particular value, this unit code, that refers to this, the unit code in this enrollment. So while the system is processing an enrollment, so it's looking at a particular value, say it's looking at student Amy, CITS 1402, 2018, scored 75. Okay. While it's processing this row in the outer query, then it will quickly calculate the average mark for every student in the same unit. So it will it will substitute 2018 for the U code. Then it will, sorry, not 2018, CITS1402 for the U code. And then it will calculate the overall average mark for CITS 14 over all of history, over all years. And if Amy's mark is less than that average, then it will be increased by 5. So this subquery has to be run once for every row of the enrollment table, because every row of the enrollment table potentially refers to a different unit. So the average then has to be recalculated for that different unit, and so on and so forth. This looks a bit weird to people who are used to writing subqueries, because normally when you write a subquery, you have to give, this uses 2 copies of the enrollment table, one in the outer query, one in the inner query. Normally you would expect to have to give an alias to the outer table, say E1, and an alias to the inner enrollment table, say E2. But SQLite doesn't allow you to give a table alias just on the outer table and just when you're doing an update. So it's a little sort of idiosyncrasy of SQLite that might catch you out. It caught me out because I had to spend quite a few minutes trying to work out why my the normal way I write a subquery like this didn't work. Okay, that's about all for DML. So I will stop now